Okay, exercise 6D is our last one on the index laws for now. It is getting a little bit tricky, so we have to just think really carefully. So here's a bit of a summary of what we've learned so far. When you're multiplying and the bases are the same, you add the powers. 3 plus 5 is 8. That can be written algebraically. So you write the base again. The powers here are m and n. We add m plus n. When we're dividing, we subtract the powers. 7 minus 3 is 4. So again, over here algebraically, you write the base, which is x, and you do m minus n. You subtract the powers. X to the power of 0 is 1. I haven't written that over there because that's as it is. And this one, we multiply the powers. When there are brackets, you do 3 times 4 is 12. Or over here, we might write that as x is our base. M times n, remember in algebra we just write mn. We don't need to write the multiplication sign. So let's have a few look at these. These are quite tricky ones. See how you go. Just do your best. So negative 3 squared, you can put that in your calculator, but put negative 3 in brackets. And it's a negative times a negative. It's going to become a positive. So anytime you square a negative, you will get a positive answer. So it's positive 3 squared, which is 9. And then with our indices, remember we multiply the powers because of the brackets. So 7 times 2 is 14. Okay, let's look at the next one. So this 4 just goes on to everything inside these brackets. So m to the 4 is our numerator. In the denominator, we've got 3 to the 4. So 3 times 3 times 3 times 3. You can do it in your calculator. 3 3s are 9, 3 3s are 9, so it's 9 times 9, so it's 81. So for a coefficient, you just raise it to the power. N squared to the power of 4, remember brackets mean multiply powers, so 2 times 4 is 8. And that's our answer for that one. Let's look at this one. Now we've got a negative out the front, we've got a negative inside. If you square a negative, it becomes positive. So this negative will become positive, but you've still got that negative out the front. So the answer is going to be negative. There are actually 3 negatives here, 1 there and 2 in there. And those 2 cancel each other out, leaving us with 1. We then have 5 squared, which is 25. We have m, and remember for indices, you multiply the powers. So 3 times 2 is 6. We have n. 2 times 2 is 4. Okay, question 4. Now this one's got stuff inside the brackets, stuff outside the brackets, lots of 2's everywhere, all sorts. It's a bit of a tricky one, so I've left space to do 2 steps here. So this 2 is a base. I'm going to write 2 times from that 2 out the front. 2 cubed to the power of 3, multiply the powers, so 2 to the 9. So I'm just getting rid of the brackets first. R to the power of 3, S4 to the power of 3, multiply the powers. That's my numerator. In the denominator, I've got 2 squared to the power of 5. 2 is my base. 2 is also my power. 2 times 5 is 10. R squared to the power of 5, so 2 5s are 10. S to the power of 5. You can think of that as 1 times 5, that's fine. And let's do some simplifying. So how many 2's at the top? We've got 9 there and 1 there, 10 on the top, 10 on the bottom. All the 2's are going to cancel down. They're all gone. With our r's, there are 3 on the top, 10 on the bottom. Let's cancel those 3 on the top with 3 of these, leaving 7 there. And the s's, we have 12 there, 5 there. So these 5 on the bottom, cancel those with 5 of these, leaving us with 7 on the top. So let's see what's left. So all the 2's are gone. With the r's, we have 7 on the bottom. With the s's, we have 7 on the top. So 7s on the top, r to the 7 on the bottom. Let's make that 7 there just a little bit bigger. Okay, this is the tricky one. So let's start by doing a few different things here. So first of all, let's get rid of the brackets. So we've got a to the 3 times 3 is 9. B to the 2 times 3 is 6. Over a cubed, b cubed, divided by a to the 4. b to the 5 times 4 is 20 over a cubed to the power of 4, 3 times 4 is 12, b to the 4. Now, if you just take it one thing at a time, you can do this. Now, we've got some choices here with how we do this. I'm going to start by changing my divide to a times and flipping the next fraction. I could be simplifying here now if I wanted to, but I'm just going to hold out on that a little bit longer. It doesn't matter which order you do these in. So I've just written that one again. Change my divide to a times, flip this one. So a to the 12, b to the 4, over a to the 4, b to the 20. Again, I've got two choices. I could start simplifying here and simplifying here and multiply later, or I can multiply first and simplify later. Personally, when I'm doing it, I usually simplify first. But I've found in the past that my students actually like to multiply first, so I'm going to do it that way for you. So let's see how many a's we've got in the numerator altogether. We have 9 there and 12 there. We're multiplying, so we add the powers. So 21 a's there. 9 plus 12 is 21. For the b's, 6 there and 4 there, so 10 altogether. 3 there, 4 there, so that's a to the 7. 3 plus 4 is 7. B's, I've got 3 there and 20 there, so 23. And now we can start cancelling down. So I have 7 a's multiplied together here and 21 there. I can subtract the powers. I might just do it that way. 21 minus 7 is 14. So a to the 14. I've put it on my numerator because there were more in the numerator. I've cancelled 7 a's on the bottom with 7 of these a's on the top. With my b's, I've got more in the denominator, so I'm going to put them down there. Subtracting the powers, 23 minus 10 is 13. I've cancelled these 10 with 10 of these, leaving 13 there. Again, they're quite tricky. I haven't set too many. Questions 3 to 6, A, E, I, and M from each one.